In the previous video, we completed the configuration file by defining the system level assumptions, value streams, calculation types, and data granularity for the analysis. At the end of that process, we selected the build program input macro, which opened up the program input file and generated the required load shape tables based on the settings in the configuration file. Now, if both the configuration and program input file are saved in the same folder with the original file names, the program input file will open automatically. Otherwise, OpenBCA will prompt us to locate the correct file. This connection helps ensure that the structure of the program input file aligns with the value streams and time series requirements we selected in the configuration file. As in the configuration file, the program input file also has a front page that includes links to supporting NSPM documentation as well as to the OpenBCA website. The program input file describes how OpenBCA evaluates program and measures specific information, including participation, savings, costs, estimated useful life, as well as load shapes that are included in the analysis. We'll begin with the Program Inputs tab. This is where we enter information that applies to an entire program rather than an individual measure. Start by entering the program name and program year. These identifiers should be used consistently throughout the workbook so that OpenBCA can correctly associate measures and costs with the appropriate program. The remaining fields capture program level values, such as administration costs, utility incentives, etc. Similar to the configuration file, the program input file also contains helper data dictionary buttons, which provide additional information and context on the specific inputs. As you enter these values, pay attention to the units and the time granularity specified in the column headers. Depending on the input, a value may represent an annual amount, a total program cost, or any other quantity. Next, we'll move to the Measure Input tab. Each row on this tab represents individual measures, technologies, or projects. Begin by entering a unique measure ID, program name, as well as the measure name. The program assignment should exactly match the one of the programs defined in the Program Inputs tab. The remaining fields here describe the other inputs associated with the measure, including measure life, measure start year, participation or installation counts, and net to gross assumptions. If any subsets were defined in the configuration file, assign each measure to the appropriate subset so that OpenBCA applies the correct system level assumptions and avoided costs. The Measure Input tab also has information for costs in the broad categories of admin, incentive, any measure level incremental costs, as well as benefits like tax incentives. If a measure has more than one commodity associated with it, enter each impact in the appropriate field in the energy impact section. This has savings for all of the defined fuel types, including electric, natural gas, as well as the other fuels. For example, an electrification measure may reduce natural gas consumption while increasing electric consumption, and it is important to denote the correct sign convention for positive versus negative savings. This tab also includes measure-specific information, including host customer non-energy impacts, as well as host customer resilience. Similar to the configuration file, the program input file also has columns for custom value streams. Each of the 5 custom value streams has their individual column where you can enter the name as well as any savings or associated impact. Now moving on to the load shapes tab. For measures with time varying electric or natural gas impacts, the next step is to define the load shapes. Here, give each load shape a clear descriptive name. This name will be available for selection in the Measure Input tab as dropdowns for both electric and natural gas load shapes. OpenBCA supports 2 general ways of entering load shapes. The first is an absolute load shape represented as kWh saved or MMBTU saved for natural gas and contains the actual savings or consumption change for each time period. A normalized load shape, on the other hand, represents a percentage of annual savings assigned to each time period and should sum up to 1. When using a percentage normalized load shape, enter the annual electric or natural gas savings on the Measure Inputs tab. OpenBCA then multiplies the annual savings by the normalized load profile to calculate the time series impact. After adding or changing load shape names, select the Update Load Shape Name button to ensure that the load shape input tables refresh. Now, the load shape, the electric and natural gas load shape tabs are where the actual time series values are entered. The structure of these tabs are generated from the configuration file. The required resolution depends on the most granular applicable value stream. If the highest electric avoided cost input is hourly, the electric savings profile must also be hourly. Enter complete profiles for each load shape name and check that time periods are in the expected order, that there are no missing values, and the profile represents the same convention used by the source data defined in the load shape name tab. For normalized profiles, confirm that the values sum up to 1, and for absolute profiles, confirm that the annual total savings represent the intended impact. Now, once you've finished entering the load shape data, before saving the program input file, perform a couple of initial checks. Confirm that each measure has unique ID and unique program name, matched across tabs, and each measure is assigned to the correct subset and load shape. Check that the savings participation, cost, estimated useful life, and NTG assumptions are complete, and confirm that all units are consistent with the configuration file. Confirm that the load shapes are also in the required format in terms of both the time period as well as normalized versus absolute, and keep both workbooks in the expected macro-enabled format, which has the extension of .xlsm, and retain the original file names. Once the files are complete, they can be uploaded to the OpenBCA user interface and validated before running the model. Together, the two workbooks provide the complete set of inputs for an OpenBCA run. The configuration file defines how the impacts are valued, whereas the program input file defines the programs and measures that are being evaluated. Once these two files are complete, the next step is to upload them to the OpenBCA interface, run the validation checks, and execute the model.